continue Chapter 3, Section 3, problem number 4. Here we have another linear programming problem. So reading this problem, we have our Ginny model of cape requires 3 hours of knitting and 7 hours to embellish the cape. The Helen model requires 5 hours of knitting and 5 hours to embellish the cape. The Jenny model has at most 60 hours a month to knit the capes and at most 100 hours to embellish the cape. So at most, we know that's our inequality, and our inequality is less than or equal to. And here you want to maximize the profit. The profit of the Jenny cape is $80 and the profit of the Helen cape is $100, which means that that is our objective function. So here you want to maximize your profit, and your profit is $80 for the Jenny cape and $100 for the Helen cape. And again, we let X is equal to the Jenny model of the cape, and we let Y equals to the Helen model. So knowing our objective function, let us continue with writing our constraints. So here are our constraints. We have an inequality to knit the cape. So here you have at most 80 hours a month. So we know at most is less than or equal to. So this is the 60 to knit, and at most 100 hours to embellish. So this is going to be our knitting inequality. In our knitting, the Helen requires 5 hours and the Jenny requires 3 hours. So we have 3x plus 5y is less than or equal to 60. And here we have the embellish inequality, and the embellish inequality is 5 hours to embellish the Helen and 7 hours to embellish the Jenny. So we have 7x plus 5y, and these two are our constraints. So now we continue with making a table and graphing the inequality. So here we let x equal 0. When x equals 0, we have 60 divided by 5, which is 12. And here we let y equal 0. 60 divided by 3 is 20. We do the same to our second inequality. When x is equal to 0, we have 100 divided by 5, and that is 20. And then when y is 0, we have 100 divided by 7, and that is approximately 14.3. So let us draw our graphs. So 0, 12, here we can draw our graphs in increments of 4. So let's do 4, 8, 12, 16, and 20, and 4, 8, 12, 16, and 20. So here we have 0, 12, and 20, 0. And this is our first line. And here at most, which is less than or equal to, means that you shade below. Less than is below the line. In the second inequality, we have 0, 20 is right here. 14.3 is about approximately there. And connect the 2 points. So here to find the corner points, here you're shading below. So again, looking at our corner points, we have 1, 2, 3, 4. And our first corner is 0, 0. Our second corner is 0, 12. The point of intersection Again, you can solve by the elimination or substitution. This point is actually 10/6. It's a little bit off, but when I solved it by elimination, this is what I came up with. And the last point of intersection is 14.3 and 0. So again, don't forget to solve by elimination or substitution, that point of intersection. So once we have all our corners, we want to substitute this into our objective function. And our objective function is 80x plus 100y. So when you substitute 0 into x and 0 into y, we have 0. When you substitute 0 into x, we have x times 0 plus 100 times 12, and that is equal to 1200. And substituting 80 times 10 plus 100 times 6, that is equal to 1400. And substituting our last corner, 80 times 14.3 plus 100 times 0, we have 1144. And our maximum number is 1400. Therefore, the maximum profit is equal to $1,400 when you produce 10 Ginny capes at 10 Ginny models and 6 Helen models. Continuing to number 5. Again, we have another linear programming problem, and here you want to maximize our profit. So let's read the word problem, and let's underline key factors here. So here we have two types of dolls. We have a baby wiggle doll that takes 5 units of raw material and 1 unit of time to assemble. And we have a sleep baby doll that takes 3 units of raw material and 2 units of time to assemble. The manufacturer has at most 150 units of raw material. Again, at most, we know that is less than or equal to, and 44 units of time. The profit for the baby wiggles is $120, and the profit for sleepy baby is $100. So maximizing our profit, we know our objective function is you want to maximize our profit, and it's $120 for baby wiggles plus $100 for sleepy baby, which means we have our x is equal to baby wiggles, and we let our y is equal to sleepy baby. So knowing our objective function, let's determine our constraints. We know at most is less than or equal to, so we have at least, at most 150 units of raw material, and at most 44 units of time. So again, at most is less than or equal to 44. So this is our raw material inequality, and our raw material inequality is baby wiggles takes 5 units of raw material, and sleepy baby takes 3 units. And then we have time, so at most 44 units of time. This is our time inequality. So we have 2 units of time for sleepy baby and 1 unit of time for baby wiggles. So 1x plus 2y, making our table. And then we will graph our lines. So when x is equal to 0, we have 150 divided by 3, which is 50. And when y is 0, we have 150 divided by 5, which is 30. And then the second inequality, when x is 0, 44 divided by 2 is 22. And when y is 0, we have 44. So let us draw our graph. And here we have, let's do our increments of 10, 20, 30, 40, 50, 10, 20, 30, 40, 50. So our first inequality, we have 0, 50, 30, 0. And here less than or equal to is below. And our second inequality, we have 0, 22 is about there. 44 is about there. And let's draw this line. And again, we have less than or equal to, and less than or equal to is below. So our feasible region is this little corner, and it's bounded by these 4 points. So let's look at our 4 corner points. Our first corner point is 0, 0. Our second corner point is 0, 22. Our third corner point, again, that point of intersection, is 24, 10. And our fourth corner point is 30, 0. Again, make sure you solve this corner by either elimination or substitution. Now, once we have our corners, let's substitute our points into our objective function. So here, plugging in 0, we have 0. Substituting 0, 22, we have our final answer is 2200. Substituting 24 into our x and 10 into our y, we have 3,880. And substituting 30 into our x, 0 into our y, we have an answer of 3,600. This is our maximum number. Therefore, our maximum profit is equal to 3,880. And at 24 cases of baby wiggles, so 24 cases of baby wiggle dolls and 10 cases of sleepy baby dolls. And that concludes Chapter 3, Section 3.